Hello, welcome to my channel. In this video, we are going to start with the problem. An air conditioner reached to a maintenance state, which is indicated by error code flag once after every start. To get the attention for repair, this AC will make acoustical sound for next 10 seconds. Create a logic for it. Once we start AC, we will receive an error code flag and that will trigger acoustical sound for next 10 seconds. Let's start. I'm going to take error code as input, so constant for the testing, and this has to be a flag data type, so the boolean data type. Then we will need 10 seconds of counter, so I'm going to create one subsystem for counter logic. Delete one add block, another add block, constant block, one switch we will need, one unit delay, and relational operator, and one add block. Too many blocks, let's place it. So for every time increment, I'm going to give 1. Then we are going to compare our output of this add block with the relational operator. So we will compare if this value is less than equal to 10. So this will be 10. If this is the value, then we will send this value. Okay. This is true, then this will be the output. Otherwise, we will send 0 value. So 1 0 we will need. Zero. And then unit delay we will also need. So we will just rotate this, and this output will go to the add. So this is our counter, and then out as output and display. So our input is ready, counter is ready. Now, which kind of logic we should connect to make this logic possible? So let's start with the enable subsystem. I'm going to make this as enable and then make this connection. Let's start with the testing 0. Now before the testing, I did some modeling changes for the easy execution. So I made my fundamental step size as a 1 and stop time as a 30 with the solver setting as a fixed step. The reason is we are going to execute for 10 steps so that we will get the 10 seconds of timer. So that execution will happen in between 0 to 30 steps total. Okay, let's start. There is the 0, there is no error code, and then we will go to the debug. We will run. After 2 steps, we are getting error code 1, and then timer should start. Here timer started, but then immediately this value will go to 0 as the requirement says. After the 1 step it will go back to 0, so we will receive this error code flag only once. So then this timer should continue, but here if we see, the timer will hold the last value because this enable has been gone. So this subsystem is no more enabled now, and that's why it is only holding the last value as per the held setting. Right? So this enable logic will not work for our requirement. Let's try some different. Rather than enable, we will try with a triggered. So we will apply trigger over here, rising trigger, because 0 to 1 is the error code flag transition we are capturing. So again start with 0. We are having 0 timer, then update with 1. After 2 steps, let's say, same, make this 1. Then timer should start. Yes, started. But now immediately this will go to 0. and the timer should continue with the increment 2, 3 and so on. But again here this is not happening. The reason is trigger of transition 0 to 1 happened only once, and that during that time this subsystem got triggered to execute, and now if this is not getting executing, it is held in the last value. So again this trigger logic will not work over here. Here comes our third approach. To make this, can we try to do some switch operation? So I'm going to give this as an input switch. So over here, if this is coming true, then rather than directly sending this value, I'm going to add one switch again, and then giving this true. Otherwise, I'm going to give the 0 value and this. But now here I have to remove this delay from here, and because this is my final output, that should go back to here. Okay, let's try this way. So this is again simple enabling the subsystem with as a signal propagation. So let's start with 0. After 2 step, again make it 1. Counter started. After 1 value, it got 0. So again counter is 0 over here. It means this logic also will not work. So the reason of giving these many different logics to solve this particular problem, enable subsystem, trigger subsystem, or the signal with the switch is not working. So what could be the another solution that we can do? And here comes the flip-flop block. We are going to set the SR flip-flop over here. Rather than directly sending, we are going to send this error code to the SR flip-flop, set condition, and then the queue operation will go to this. Now let's see what happens. So we have to also cover these two blocks just for the compilation purpose. For now, we will not giving any logic to them, and these are 0 0. Okay, looks good. And then execute. Let's start with 0 over here. For the first two steps, 0. Now we receive the 1. Timer started. Make this back to 0. Timer should continue. So here we see now the timer is getting incremented. So SR is giving that solution. Now until 10 step it should be continued, and then it should go back to 0 because we say acoustical sound should play only once for the 10 second. So 7, 8, 9, 10 and done. But if we execute further, what do we see? It goes to 0 but again started. So this is not what we are searching for. We want only once, and that's where we have to connect back to the reset. So we are going to take this output. So let's stop this execution, and then I'm going to add one unit delay over here, and then just flip this again. Take this value, and what should be my condition over here? If this value until 10 this is okay, the reset should not happen, but when after 10 it becomes 0, at the time the reset should trigger again. So when this becomes 0, the previous value which can come to the unit delay will be 10. It means unit delay will be compared with 10 value. So I'm going to give one constant over here and then compare with the 10, one relational operator, and make this condition as equal. Connect these two, and now let's execute again. After 2 steps, we are receiving error code 1. Timer should start. After 1 step, it will go back to 0. Timer should continue till 10, 7, 8, 9, 10, and again it should go back to 0, and it should not further start the timer. Looks good. So this is the output. Now how do we run the acoustical warning over here? So let's give one more output over here. out. Then I need one relational operator. And if I execute now, I should start with 0, 0. This flag which I am creating, Boolean flag, should be used for running the acoustical sound. So for first two step, again 0, 0, now 1, and this is 1. This remains true until the value ends 10, 8, 9, 10, and again it should go back to 0. Now let's understand the why this SR flip-flop is behaving in such a way. So I'm going to create one table for this. Here S, R, then these are the S and R are the inputs which we call as set and reset. Now we will create output Q and complementary Q. Let's create a truth table 0, 0, then 0, 1, 1, 0, and 1, 1. Okay. In this case, what should happen? When both are 0, 0, then we should hail the previous value. So whatever Q value has, the last value, that should have been captured. So let's assume when it was 0, and then unit delay has 0 value, set is 0, reset is 0, there is nothing that Q should re-trigger and capture the new value. So whatever the previous value Q had, it should remain with the previous value. So what should be my answer over here? Prev. Okay. In this case, now when my set is 0 and reset is 1, in that case my Q should become 0. So that's where when we got this value 10 and this flag was 0, we have reset Q becomes 0. So this inside it becomes 0 and we stopped our timer because this value became 0 and this has been set directly. So here in this case, when set is 0, reset is 1, Q became 0, right? Now let's take third case when set equal to 1 and reset is 0. So the first time when we got the error flag as a 1 value for one step, this set becomes 1 and then Q becomes 1, so that this timer got triggered, right? And there was no input from the reset side. So in this case, it should be 1. 1, 1 case. Now the fourth case where both set and reset are 1. This SR flip-flop has been not designed to handle this situation. This is an invalid situation, and ideally our logic should not go in such a way that both set and reset are true at a time. So this is being called as an invalid, and then there is no result for this invalid. Then we come up with the fourth part, complementary Q. Complementary Q is nothing but the negation of the Q value. So when we have this previous value, anything previous values negation will be shared over here. 0 will get converted into 1. So let's write it like this. Negation prev. 0 will become 1 over here. It will become 0, and this invalid will remain an invalid case over here, or I should write invalid better. So we don't expect this operation at all. Now let's execute one more time with this table understanding. When both are 0, Q has a previous value, so whatever the previous value it is capturing, it will remain as it is. Now after two steps, we are going to give this as a 1 value, and then Q has to become a 1 over here because the set is 1. So this is happening, set is 1 and Q is also becoming 1. Now set has to be 0. So both are 0 0 now. So Q has to still capture the last value. So Q will remain true until reset is not coming now. 9, 10. Now reset should come. So R should become 1 and then this is already 0. So second row over here 0, set 0, reset 1 should happen. And then Q became a 0, right? And then it should continue in that way. Hope you like this video. Thank you so much for watching. See you in the next video.